Good morning everyone. This is Saranya S, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women, Hosur. Now I am going to discuss about Heisenberg's principle in quantum mechanics. So let me discuss about the statement of Heisenberg's principle. So it is impossible to determine precisely and simultaneously the values of both the members of pair of physical variables which describe the motion of an atomic system. So such pairs of variables are called canonically conjugate variables. Example: according to this principle, the position and momentum of a particle or electron cannot be determined simultaneously to any desired degree of accuracy. Here del x and del p, which is greater than or equal to h cross by 2. So del x means position of the particle, del p means momentum of the particle, h cross is h by 2 pi. Similarly, the energy and time cannot be described simultaneously. Example: del E and del T, which is equal to h cross. And angular momentum and angle cannot be described simultaneously. Example: del J and del theta, which is equal to h cross. Here look at the picture. He is the Werner Heisenberg. The more certain you are about where the electron is, the less certain you can be about where it is going. So he found the electrons which cannot simultaneously determine both the position and momentum of electrons. The product of the two errors is approximately of the order of Planck's constant. If del x is small, del p will be large, and vice versa. It means that if one quantity is measured accurately, the other quantity becomes less accurate. Thus, any instrument cannot measure the quantities more accurately than predicted by Heisenberg's principle of uncertainty. The same relation holds for the energy and time related to any given event. Here del p and del x greater than or equal to h by 4 pi. So h means Planck's constant and del p means position of the uncertainty and del x will be momentum of uncertainty. According to the classical ideas, it is possible for a particle to occupy a fixed position and have a definite momentum, and we can predict exactly its position and momentum at any time. But according to the uncertainty principle, it is not possible to determine accurately the simultaneous values of position and momentum of a particle at any time. Here look at the picture. Uncertainty principle: due to position and momentum of the particle cannot be determined simultaneously. And second picture located as the illustrations of the uncertainty principle. And third located at three possible conditions which cannot be simultaneously determined by uncertainty principle. The first illustration: position with the gamma ray microscope. How to determine? Suppose we try to measure the position and linear momentum of an electron using an imaginary microscope with a very high resolving power. The electron can be observed if at least one photon is scattered by it into the microscope lens. The resolving power of the microscope is del x equal to lambda by 2 sin theta. Illustration 2 represents diffraction of a beam of electrons by a slit. A beam of electrons is transmitted through a slit and received on a photographic plate P, kept at some distance from the slit. We can only say that the electron must have passed through the slit and cannot specify its exact location in the slit as the electron crosses it. Hence, the position of an electron recorded on the plate is uncertain by an amount equal to the width of the slit del y. Let lambda be the wavelength of the electron and theta be the angle of deviation corresponding to first minimum. From the theory of diffraction in optics, del y which is equal to lambda by sin theta. This is an uncertainty in determining the position of electron along the y-axis. Here del y and del py greater than equal to h by 2 pi, which is Heisenberg's uncertainty principle. Thank you.